All right, so we can take a look at the second part of 3.1. Okay, it's still on inverse trig. And we learned yesterday that inverse trig and regular trig basically do what to each other?
Reverse each other.
Right, they reverse or they cancel out. So let's look at this one. Okay. What this formula is saying is what you just said. If you pick something and plug it in for x, and you take the sine of it, and then you take the inverse sine of that, those two things are going to cancel each other out. And the answer that you're going to get here is whatever you started with when you typed it in. So let's try an example. Let's take the inverse sine of, okay, and just to be clear, that does not mean multiply. Okay, there's no multiplication anywhere on the board right there. This just means the inverse sine of the sine. It's kind of like if I wrote this. That does not mean square root times 8. Even though there's an 8 right next to the square root symbol, that doesn't mean multiplication. It just means square root of 8. That's all it means. Same thing here.
So it's the inverse sine of sine x?
Yep, it's the inverse sine of the sine of x. That's how you say it. You say of. Yep. Just like here, you say square root of 8. You don't say square root times 8. There's no times in that problem. Okay. So let's try typing one in. Inverse sine of 74. Based on that formula, when I hit enter, what should I get? Yeah, I basically get back what I started with. If I do inverse sine of negative 18, what should I get when I hit enter? Yeah. These two things cancel out, and I get that back. Now, let's try one more. Let's try 100.
Is it 100?
Well, what did we say yesterday? When we do inverse sine, we always get an answer between what?
1 and 180?
Negative
90 and 90.
Negative 90 and 90. That applies to this formula. So if you plug in a number that's not between negative 90 and 90, then no, it won't work. So for this...
What is the answer then? Like, what does it say? Press enter.
No, it's 80. It says 80.
We got a different answer back. Okay? But the more important thing is just to remember when this formula works. If you plug in a number between negative 90 and positive 90, that's when you get the same thing back.
So are we like not allowed to do it if it's over 90?
Yeah, well, it doesn't work.
Alright.
Yeah, so you stay between negative 90 and 90.
Are we going to figure out how to solve it later on?
No, not
Didn't you
really.
just show us? It's 80, right?
Yeah, I showed
You
you,
just put it in the calculator?
Yeah,
we're never really going to do that. No. I just wanted to show you if you pick a number that's not between negative 90 and 90, this formula doesn't work. Okay? All right. How about if I did this one? Let's do 13.5. What would I get back the same thing, or would I get back something different?
13.5.
Yeah. Okay. I get back the same thing because I plugged in a number between
Do you
negative
have like
90
10
and
of these
90.
questions on the quiz?
You'll have at least one.
Like
or two.
10?
Maybe one.
Wait,
3?
I don't think it's on the test actually.
4?
Does it work? Does this work for tangent too?
We're going to talk about the tangent,
Does this work for
the
all of
sine,
them?
and the cosine. We're going to do each one. Yep. Okay. So now look at formula 2b. If you look quick, it kind of looks the same, but it is a little different.
The negatives on the inside.
Yeah, so in this one, that -1, that inverse sign, is on the inside. Okay, so what's the difference?
It's on the inside.
It's kind of like if you did this. If you took 3, you squared it, and you square rooted it. Or
Oh, so it just stays the same?
you did that. Okay, what it is, it's order of operations. It's just you're doing both, but which one are you doing first? Here, you're squaring the 3, then you're square rooting. Here, you're square rooting, and then you're squaring. With squaring and square rooting, it doesn't matter. With trig, it does.
So the answer is
So if you type in, let's try the sine of the inverse sine of 0.4. Okay, I put the inverse on the inside. What you get back is what you started with. So what do you think I should get when I hit enter?
0.4.
Yeah, I get 0.4.
Huzzah.
But this one also has a limit, right? The other one was negative 90 to 90. I want you to look at this picture. Okay, that's a picture of what sine looks like. Okay, it's a wave.
Sine wave.
Yeah.
We use those.
What's the highest
1.
that it looks like it goes?
1.
And how about the lowest?
1. A little bit under negative 1, I feel. No.
Negative 1. Yeah. Because of that picture, okay, because this wave only goes as high as 1 and as low as negative 1, that's where that 1 and negative 1 are
So it
coming
has to
from.
be a decimal?
Yep, it has to be a decimal between negative 1 and 1.
That
Okay,
sucks.
so let's try another one. Pick one that would be
0.1.
between. Okay, so 0.1, that's going to work fine.
So what happens?
But if you do anything over 1, will it not come back as the same answer?
I'm good.
Well, if you do something over outside what you're supposed to use,
Will it just give you a number that's inside what we're supposed to use?
it's basically like asking this question. Let's do 1.5. Where does the line of the wave cross?
Never.
Never. So there is no solution when you try to plug in a number like 1.3. It can't do it. Right? So not only do you not even get a different answer back, you don't even get an answer back because 1.3 and that wave never cross each
So
other.
its range is negative 1, 1?
Yeah, you have to be between negative 1 and 1 for that formula to work.
No, that's for like when it's the normal.
Okay, what's another number that would work?
0.2.
0.2 or 0.23.
0.23.
Okay, so what I'm showing you with those two formulas is when inverse sine and regular sine cancel out. Okay? As long as you fall between these two numbers, it'll cancel out in this situation. And what did we say for the first one? Between
Negative 90 and 90.
negative 90 and 90. Okay. So this is the kind of question you would see on the test. It says, is the inverse sine of the sine of pi over 8 equal to pi over 8? So the answer is either yes or no. Okay. First thing we want to do is look at your formulas and figure out, is this formula 2a or is it 2b?
It's 2A.
It's 2a, right? The inverse is on the outside, inverse is on the outside. What does it say we're supposed to be between?
Negative 90 and 90.
Negative 90 and 90.
Wait, but that's pi over 8. This
Wait,
is pi
what?
over 2. So how can that
So
be
what's that pi over 8? What is that?
a radian?
It's a radian. So if we want to check if we're between negative 90 and 90, we can change to degrees. How do you change that to degrees?
180 divided by pi.
180 divided by pi. Now, we don't even have to figure it out exactly. We know we're supposed to be between negative 90 and 90.
You get 22.5.
If you take 180 and you divide by 8, is that going to be smaller than 90?
Yes.
Yeah. If you take 180 and you divide by 2, you get 90. So if you divide by 8, it's going to be even smaller. So it is going to be between negative 90 and 90. So would this be yes or no?
Yes.
Yes.
I have a question. Can you also use the pi over 2?
I would just do it with the pi over 2. Yep.
Because, okay.
Yep. I would just keep it in units.
Yeah.
But if you want to do degrees, you can, because some people find degrees easier.
Does it work if it is 90?
Yes, because there's an equal to.
Oh, okay.
When we get to tangent, you're going to notice a difference on that. So,
Sounds
yep.
good.
Okay, how about that one? Okay. Inverse sine of the sine of 3 pi over 2. Okay. First of all, 2a or 2b?
2a.
It's 2a. Inverse is on the outside. Let's try to keep it in radians this time. What's the biggest that we can go for radians?
Pi over 2.
Pi over 2.
So it wouldn't work.
So no, because it's more than pi over 2.
Yeah, so think of this is the zone where everything works. Between negative pi over 2 and pi over 2.
So that's 3 pi.
Over here, no. Over here, no.
Wait, I don't get it. Why is it in radians?
They just, you can do radians or degrees.
Oh, it doesn't matter.
It doesn't matter.
Okay, okay.
So now, is 3 pi over 2 in the green section? No, 3 pi over 2 is triple pi over 2. It's like way over there. So if we type that in, would it work?
No.
No. Okay, that's the one where if you type it in, you will get an answer, but it's just going to be a different one than you started with. So no, doesn't work. Okay. How about this one?
2B.
That's 2b. Inverse is on the inside.
Yes.
What are we supposed to be between in formula 2b?
No.
Negative 1 and 1. Is that between negative 1 and 1?
No.
No. Is the answer there? No. Okay. How about this one? The sine of the inverse sine of 0.6.
Yes.
Yes. Okay, those would cancel out. That's formula 2b. And that number is between negative 1 and 1. Now, what if I wrote this? Simplify. And I did sine the inverse sine of 0.37.
It would be 0.37.
Right.
So you just write 0.37
Yes.
and that's the answer?
Correct. You do not write yes for that one. That's not a yes or no question.
Yes,
Absolutely.
What if I did?
definitely.
Absolutely.
I think you get it
Then
right.
we get it wrong.
Yeah.
But like it says yes.
So if it says simplify, that means you need to reduce that and turn it into a number. If it says is something equal to something, that's a yes or no question. All right, let's look at cosine. Okay, so same thing with cosine. The cosine and inverse cosine will cancel out. As long as x is between certain values, and we talked about these values yesterday.
0 and 180.
0 and 180. Yep. If you're doing radians, it's 0 and 0 to pi. If you're doing degrees, 0 to 180. If you plug something in like 190, you can plug it in, you will get a number back, but it won't be the number you started with. This is the one that will give you an answer back, always. Okay. Formula 4b. Okay. What's the difference between the 4a and 4b?
The opposite's on the inside?
Yeah, the inverse is on the inside. And the way I explained to you how this one worked is I graphed cosine, and we looked at how high and low it goes. That's sine, so just let that one finish. And the one you're going to see in red is cosine.
Oh, it's the same.
It's the same, right?
Just different interval.
Yeah, it's been moved to the left or the right a little bit, depending on how you look at it. But the highest it goes is how high?
Hit 1.
And the lowest?
Negative 1.
Negative 1.
Right. And that's why this is again 1 to negative 1.
But why isn't normal cosine not the same? Because that only goes up to 1 and negative 1.
So the red one is normal cosine.
Yeah.
Yeah.
So why isn't that one the same? Why is this one 0 and 180 and this one only negative 1 and 1? But they're both cosine.
Oh, this has to do with what we did yesterday.
Okay.
That's why. That's different, yeah. This has to do with the picture that I'm showing you.
Okay.
That comes from what we did yesterday.
I get it.
Yeah. So, yeah. All right. So let's try that one. Is that one formula 4A or 4B?
4B.
4B.
Yep. That one has the inverse on the inside. What are we supposed to be between for that formula?
Negative 1 and 1.
Okay, and what are we at?
0.95.
So yes
So
or no?
yes.
Hooray.
Woohoo! I thought you were already fixed.
Okay. The bottom one, now
That's
the
A.
inverse is on the outside.
That's
So
A.
no.
No.
Boo.
Okay, inverse cosine on the outside, you're supposed to be between 0 and 180. We're more than that. We're at 210. Okay, so you will get an answer back, but it will not be the answer that you typed in. So, any questions on those two?
The whole test should be used.
Well, we'll have a couple.
How many questions are on the test?
Probably between 15 and
15
14
and
to
5
17.
That's a lot.
yeah. 14 to 17 questions. That's a lot.
Yeah.
I can't even count that high, man.
You'll be okay.
No.
No. Well,
Are you sure I can't do Algebra 2 next year?
I'm sure.
Unfortunately.
All right. Let's look at the tangents.
Let's.
Okay. Let's not.
Yeah.
Why?
Because I don't want to.
Oh.
I bet it's easy like the other ones.
Okay.
No,
You
but
said
it's
that.
different because there's no equal to sign.
That's okay.
So it just means you can't use 90.
So inverse tangent of regular tangent. These two things will cancel each other out. The answer that you get is whatever you started when you typed in. But what did we say yesterday we had to stay between for a tangent?
Negative 90 and 90.
Negative 90 and 90. Okay, the difference, I told you I'd point that out, you can't equal the 90. Okay, you're strictly between negative 90 and 90. Let's just try one. So give me one that would work.
25.
The inverse tangent of the tangent of 25. Yep.
25.
Get back 25. Now, another reason you might not get the same thing back is if you are in radians and you type that in, you will not get the same thing back. Because this is as high as you can go in radians. That's 3.14 divided by 2. It's about 1.5, 1.6. That is way beyond. So if you're not getting the same thing back and you think you should be, double check your mode.
Okie dokie.
All right, and 6b, the other way. The tangent of the inverse tangent. Okay, so this is the one that I always explain with the graph. These two graphs we're going to study. That, well, I zoomed in, so now it looks like it's a lot different. That's sine, and the one in red is cosine. We're going to look at those graphs next week. The graph of tangent, we're going to look at it right now, but it's not a graph that we're really going to study in depth. But remember,
How do you study a graph?
You look at it.
we talk about like it's how high it goes. We talk about how fast it goes up and down, things like that.
Graphs move?
Well, this one oscillates up and
Oscillate?
down.
It sounds like an animal.
Yeah, it oscillates. So I want to look at tangent, and the question is going to be how high and low does it go? And that's going to tell us what this has to be between, okay? Just like the other two. So if we look at tangent,
Forever.
there's definitely a pattern to it. It does repeat, like the blue and the red
It
wave.
goes up and down forever.
But yeah, it goes up and down forever. So what do you think that means this number can be between?
Infinity.
And
Infinity.
negative infinity, yeah.
Oh, I was right.
So what that basically means is formula 6b
I'm
works
so excited.
all of the time.
Awesome.
You can't find a number that wouldn't work. As long as you plug in a number.
That sounds easier.
So how about that one?
It'd be correct.
Yes.
Of course it's correct, right? Inverse is on the inside. As long as you pick any number, it's going to work.
Oh, sweet. So you like that one.
So that one always works. Any questions on those two?
No.
Okay, you don't have to know that this is 6a and 6b. That's just the formula your book uses. Just the name they call it. Why?
No.
There's a fly.
Oh, a fly. They said why. I don't know why the book uses that. Okay, so that's the first one. Now, any questions on what we just did from?
I liked this
from that?
unit.
Are we?
Right here.
No, we're not done. No.
Time for homework?
No.
Time for nap?
Time for 4.1.
No.
Take one anyway.
Yes. I love 4.1.
Yep, 4.1. It's fun.
I don't.
This is my favorite section.
Yep,
Wait,
mine
wait,
too.
Right triangle, no.
Right
I don't want triangles.
Okay, so we're going to look at 4.1. That's the last section. We're going to split it up into 2 days. So we'll do half today, and we'll do half tomorrow.
Coolio.
Okay. So first thing is it's all about right triangles.
Really?
Great. Yeah. So the goal is going to basically be eventually to figure out, if I give you some information, how long are all the sides, and then how big are all the angles. Well, we're dealing with right triangles, so let's start with that. What,
90 is going to be 90.
One will be 90.
one angle is always going to be 90, and there's a name for the side across from the 90.
Hypotenuse.
Hypotenuse. And how about the two short sides?
Legs.
Those are called the legs. Yep. That's everything we just said.
Correct.
So I got a right triangle, always has a 90. 90 is represented by that symbol right there, the little square. Hypotenuse always has to be the long side, and then the other two legs are the short sides. The legs don't have to be equal. You could have something.
Well, isn't a right triangle always the same?
No.
No. How?
We
How
could
can
have
it ever
different,
be different?
different sizes.
But not different angles. They're
Yeah.
the same angles every time.
No,
Right?
no.
How
These two
One side
triangles
can be
don't have the
shorter.
same angles.
One side can be shorter
What?
and the other side can be longer.
I mean,
What do you mean? It's always gonna be, there's always gonna be 190
Yeah.
so you
and then
think
245.
you think that angle is the same as that angle?
Never mind.
They all have to add up to something.
What
Natalie, we were thinking
Yeah.
the same, right?
180.
You're up here, Natalie.
Okay.
I always have the same dumb answer.
So,
And we're always in the same class.
that's okay. Well, we're
Hey,
fixing
there's no-
misconceptions. That's what we
there's
do
no dumb
here.
questions.
So yeah,
Unless you're
We
all
wild.
the angles have to add up to 180. What is an acute angle?
Smaller
Something
than
less than
90.
Okay, smaller than 90.
Good job, guys.
Guys, I know these
Is that all
questions.
that?
Well, something to do with acute angles.
Can we just grab acute angles?
It's
What else though? It has to be
it'll
smaller
never
than
be
90.
equilateral.
That's
It
something
can't be a
else.
right
More
triangle.
than 0 maybe?
It has to be more than 0.
How can you have an angle less than 0 on a triangle?
In a triangle you can't, but remember when we rotated on the unit circle, we had negative angles?
Yeah, but for a triangle,
Right, for a triangle you can't.
could you ever have a negative angle on a shape?
No, that's why it says
No.
it has to be greater than 0.
No.
Not
That's
about a
why,
triangle, they're about any shape.
that's why when we talk about shapes, we always talk about positive angles. The only time we do
Guys, let's get on
negative,
track.
the only time we do negative is when it's on a circle, and that's a different
I
direction.
see.
Yeah. Okay.
There used to be a lot of juking around.
What about, there's a theorem connecting all the sides of a triangle,
A squared
Triangle
plus b
theorem.
squared equals c squared.
Pythagorean.
and that's the Pythagorean theorem.
I'm on a roll.
Good,
How do
that's
you-
good. Good, I like the enthusiasm.
Fact.
Now, you said somebody said a squared plus b squared equals c
Me.
squared.
That was me.
What, I don't really have any a, b's, and c's in this
I'm
diagram,
seeing an A, B, and a C.
so,
Wait.
The A is the short leg, the B
B
is
is
the
the other
long
short leg, and the C is the hypotenuse.
there we go.
Holy shit.
This is the most enthusiastic I've ever seen.
So as far as A and B, you can let them be either leg. It doesn't have to be the short or long. But A and B have to be the legs,
Yeah.
and C is the hypotenuse.
Yeah, I was correct. What was that?
You guys are cooking.
Put this on the test.
So
We should
this,
get a smarter class.
okay, this is a theorem.
Put me in honors.
That's a theorem you can only use in a right triangle. And there are right triangles that are not right triangles,
They're
I'm
wrong.
not that.
like that.
That's an obtuse triangle.
Yes. So for this week, we're not looking at these kind of triangles.
Good.
Oh, you're
I like
like
those
Albert?
ones.
Yep,
Next
that's the week after. Graphing is next week, and that's the
Oh,
week after.
oh, graph what?
Thank you.
What are we graphing?
You're so welcome.
You should go to honors.
Nope.
Stop goofing around, Aiden Withers.
Okay, so the next thing we want to look at is the definitions of the 6 trig functions. So I'm going to give you
Haven't we been doing
definitions.
this?
What's that?
Haven't we been doing that?
Well, we did it with unit circle, right? We had sine was y, cosine was x. We're going to define them with different words, but it still is the same concept. It's pretty much
I don't
exactly.
think it's a good idea.
I do not agree.
It's the same thing.
It's okay, guys. We're gonna get through
You'll
this.
be okay. So the terms we're going to use are opposite, adjacent, and the last one was hypotenuse. First thing is make sure we understand what those are. Okay. Opposite and adjacent, they're what we call relative terms, meaning they're from a certain perspective. So for me, they would be like left and right. Okay? Because I'm facing you, left is the door, right is the windows. For you, it's reversed. Right? right is the door. and
Is this
left
like
is the window.
the opposite one is one of them and the adjacent side is one of them? Because I
Yeah.
think we did this last year in geometry.
Yeah.
Isn't opposite like wait, no, isn't adjacent the one across from the main?
I'm gonna show you in a second. Yeah. Okay, but we just have to understand that opposite and adjacent
Are different.
are different. It depends on the problem. Okay, it's like in this room, you can't label one of these walls left. There is no wall that's always left. It depends on how
Is
you
there
say
something
it.
that always is left?
Like up. Up is always the same.
Up is always
Yeah.
down.
Okay, and down, yeah.
It depends on if you're doing
Yep.
it.
So
No.
with hypotenuse, that one always stays the same. Hypotenuse is always across from the 90,
I see.
just like up is always
Always
towards the
up.
ceiling. Yeah, opposite way to up.
Would that change if you were doing a handstand?
No, gravity doesn't change.
Okay.
Opposite way of gravity is up.
What if I could change gravity?
Oh my gosh.
You can't.
Well,
Okay, so
are you
let's
gonna make a new rule or a new law too?
Yeah.
look at that
The
triangle.
will law.
Oh, is that theta?
Yeah, so what we do, because we need a reference point, like which way are we facing? This, that's our reference point. So it's
So
like
theta?
we're standing right there. Yep,
So
theta.
whichever one is more to the right we pick, whichever one.
So when you're trying to figure out which one is opposite, opposite is the one that is farthest away. It doesn't touch either side next to it. So which one would be opposite in this picture?
The leg across.
The left one.
Yeah, the left side. Adjacent is one of the sides that's right next to your angle,
Wouldn't it
but
be-
it's not the one that's the
So it's the
hypotenuse.
bottom one.
Yeah. So it's always the one that's next to your angle, but it's not the hypotenuse. Okay? Now, same triangle, but this time your reference point is going to be from the top. So which side is opposite now?
The bottom one.
Right. Opposite is the side that's farthest away. Doesn't touch either of the two sides that are making up your angle right
And
there.
then then adjacent would be the one to the left.
Yep, adjacent is the side that's next to it, but not the hypotenuse. Okay, so the point is opposite and adjacent will switch places depending on which angle you are referencing in the triangle. Just like left and right switch places. Okay. So if you're looking for a definition, again, opposite is the side in the triangle that has nothing to do with the angle. If you have a triangle and you erase the opposite side, you would still have an angle right there. No problem. That side had nothing to do with that angle. For adjacent, if you erase the side that's adjacent, you don't have an angle anymore. Your bottom of your angle is gone.
On like the test or questions, are they gonna show you where theta is?
Mhm.
Okay, so we don't just have to guess.
No. I will always tell you where it is.
Okay.
Okay. So adjacent is the side in the triangle that's right next to the angle, but not the hypotenuse.
Mr. Hager, what's your favorite math subject ever?
How about you shut your mouth? We're trying to learn here.
Well, I mean, I'm not really.
Whoa,
Sorry.
I take offense.
I apologize.
It's okay.
I like trig. Trig is good.
Why do you like it?
It's relatable to a lot of different things.
What's
You
your
really
top
relate to
five?
trig.
Yeah, I can. I
Can
guess
we
I
get a tier list?
find applications for it.
What's your least favorite?
Probably geometry. I'm not
But
a-
this is like geometry, I know.
It is like geometry of a triangle, so I guess I like
Do
just
you like
triangles.
stats?
No. No, I'm not really a stats. That's a different.
Can't wait to
You
take
like
it next
it?
year.
What's
So
that?
you can take it next year with us.
What would you do if I was your classmate?
Wow. I think he might be in trouble.
All right, so let's look at the 6 trig functions.
Okay,
So we have
Ready.
sine, cosine, tangent,
I'm so down.
and what are the other 3?
cosine,
Cosecant.
Cosecant,
cotangent.
cotangent, and
So you can't.
secant. Yep.
Good job.
And what we're going to do now is define the 6 trig functions
Oh, I have a table.
as a length of one side in a triangle divided by the length of another side.
This is on your
We did this in
like
geometry.
MCAS thing, your
What?
MCAS reference sheet, isn't it?
Yeah, I already forgot about that because I'm not taking it ever yet.
Wasn't catastrophic.
Why are you so aggressive?
Oh, I know this stuff.
Yeah. All right, and then if you have trouble remembering it, Sokotoa, sometimes it's a word people use to remember it.
I hated that.
I will not be remembering it.
So
Nope.
what that is it means sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. It's the first letter of each one. Tangent is opposite over adjacent.
Isn't that one lady that found America or something?
That's
Sacagawea.
Sacagawea.
Oh.
She didn't find America. She was already living here.
Yeah.
Johnny Appleseed fell on the other hand.
So
She did not
Sokotoa.
find America either. What?
All right, now, once you know those three, what do we always do to get the other three?
Flip them.
We flip them. So which trig function, what's the name of the one you get when you flip sine? No,
Cosecant.
cosecant. And that would be what over what?
Hypotenuse over opposite.
Yep.
Oh.
Okay. What's the name of the one when you flip cosine?
Secant.
Secant, and that would be,
Hypotenuse over adjacent.
yep.
And then cotangent.
Cotangent.
Oh my god.
Adjacent over opposite.
Adjacent over opposite. Yep.
She got this.
So if we know the three on the left, we automatically should know the three on the right because you just flip them. Also, when you are finding a trig function, like let's say you're doing tangent. Let's say the opposite side was 4 feet.
Wait, there's only two there. Where's it there?
He scrolled down.
He scrolled down.
So let's say opposite side was 4 feet and the adjacent side was 3 feet. What cancels out there when you divide?
The feet.
Right, because you have the same unit in the top and the bottom. The unit is gone. Okay, so the point when you are finding a trig function, it's just a number. There's no radian, no degree, no feet, inches. It's just a number without a label. Okay.
Can you have triangles that have like different units for each side? Is that a thing? Or like what is it?
You'd have to make them all the same, but yeah. Yep, you just have to make them all the same. All right, so what we want to do with that is find the 6 trig functions of theta. So first thing is they have to give you a diagram. Second thing, they have to put theta in the diagram somewhere. Third thing, they got to tell you 2 of the sides. Let's label the positions of each side. What position is the side that's 4 units up?
Opposite.
That's opposite.
Whoa. Whoa. Adjacent.
And then adjacent. And which one's the hypotenuse?
The last one.
The last one. Okay. So if we want to find all 6,
Bye, Skippy.
right now we can only find ones that have opposite and adjacent. We're missing hypotenuse.
Did we solve?
We should find hypotenuse. Yeah. Before you start doing any of
Wait, how do you
this.
solve a triangle like that? I don't remember how.
how
A
do-
squared plus
Oh.
B squared equals C squared.
I knew that.
Okay, so this side would be A, B, and C. Okay, so what would my Pythagorean theorem look like?
3 squared plus 4 squared equals C squared. 9 plus 16
So 9 plus 16
C equals 5.
is how much?
25.
So that's 25.
And then you square root it, so it's 5.
And then we square root it. So it's 5.
Hey, yeah.
So that's the first thing. We have to find that. Now, let's go through all the trig functions. Start with sine. What's the definition for sine?
Opposite over hypotenuse.
Yep. So in this case, it's
4 and 5.
4 over 5.
Obviously easy.
Now, this time we got lucky because the hypotenuse was not a square root. If the hypotenuse
Oh,
comes
so
out to a
that-
square root,
That'd
like
be kind of goofy.
square root of 7,
Which we're going to be doing one of those.
Aww.
can't leave the square root in the bottom. Okay, so we've already
So you
practiced.
just multiply by the square root on both
Yep.
sides and get rid of it?
We've already fixed that before when we did the unit circle. Yep.
Easy peasy.
How about, what's the definition for cosine?
Adjacent over hypotenuse.
Okay, what's the adjacent?
3.
And the hypotenuse?
5.
5. What's the definition of tangent?
Opposite over adjacent.
4 over 5.
Opposite over adjacent?
Wait, 4 over 3.
So 4 over 3.
And then hypotenuse over opposite, so that'd be 5 over 4.
So that's your
And then 5
cosecant.
over 3, and then 3 over 4.
So secant is
5 over 3.
5 over 3.
And then 3 over 4.
And and 3 over 4.
I think Cassie should get a gold star.
Yep, very good.
Come on now.
Okay, now just to make sure we understand what we did not find theta. Like we didn't figure out how many degrees
It's
it
already
was.
there, right?
Well, it's labeled, we don't know how big it is.
Do we need to?
Tomorrow we'll figure out how big it is.
Oh.
But do we really have to?
You really have to if you want to hope to get the question
If I
right
don't
on the
want
test.
to.
Yeah, I'm
Well, if you don't want to, then you might get the question wrong.
No.
Yeah.
How about you just give me 100?
So
Test.
if we, which we are tomorrow, we're going to solve for theta. That's preventing theta from being alone. How do you think you would get rid of sine?
Divide by sine.
You do the negative, the
The inverse.
that's the one.
You'd have to do the inverse sine. And if you did inverse sine in this problem, it would cancel the regular sine out. If you did it on the other side, you would get the answer for theta. Okay? So for today, we're just practicing finding the trig functions. Also, on the test, I would just say, using this diagram, find cosine of theta. So all you'd have to do is write 3/5.
Oh, I got it.
Or I would say, just find cosecant.
We're not gonna find all 6.
You're not going to do all 6 in the same question. Yeah. I'll probably give you different diagrams and say, in this one, do the sine, this one, do the tangent, this one, do cosine.
You should
Yep.
give us one for all 6. Have it count as like 20 points. Complementary.
All right,
angles.
so
Oh,
last thing. What does it mean if angles are complementary?
They're the same, right?
They add the
That means congruent.
They add to 1/5, 80.
They add the
So supplementary means they add up to 180.
They are
equal
across
90.
from each other.
The 90.
Those are vertical
They add up
angles.
to 90.
They add up to 90?
Yeah.
Are you sure?
Yes.
Mhm.
Yes.
Wait,
Please.
yeah.
Yes.
Yes.
Supplementary added to 1.
Shut up, we just said that.
Please, this hurts my head.
I was right the
So
first time.
complementary
Yeah.
angles are angles that add up to 90. Okay. Let's look at that diagram. We'll call that angle 1 and 2. Usually we use Greek letters, but for now I just call it 1 and 2.
Why is it always Greek?
Just
that
to
was in the first
differentiate it from the
language.
English letters being
Do
signs.
they make the best pizza?
Oh, why Greek instead of other
Yeah.
other languages?
It's
Why
probably-
not English?
Well, we do use
Girl.
English.
I think the mathematicians were cultivating these like
What do we know about all of the angles in a triangle?
180.
They all equal 180?
Yeah, it
They
added
add
them
up.
together.
They add up to.
Yeah, they all add up to 180.
What's the difference?
Well, if they all if they all equal 180, you're saying that's 180, that's 180, and that's 180. They all
Oh.
equal 180.
Together, they all equal 180.
Okay, together they all. Okay.
That's better.
So angles. So we know this is how much.
90.
That's
So
90.
45.
So what do we know about these two?
36.
They're
the same.
complementary.
They're complementary. We don't know if they're 30 and 60. It depends on how the triangle is drawn. Could be like 20 and 70. We don't know.
Yeah.
But they do have to add up to 90, which means
They're
Complementary.
complementary.
they're complementary.
Angles.
Okay. So the two acute angles in a right triangle, the two small angles, are always complementary.
We dropped something.
Jesus Christ, Cassie, break.
Okay, so keep that in mind.
How
The two acute angles in a right triangle are always complementary.
always.
Okay. So, next thing I want to look at, we're going to tie this in with complementary, or what are called cofunctions. Okay, the way we've been pairing up trig functions now, these are called reciprocals. Sine and cosecant are reciprocals because you flip one to get the other. Cosine and secant are reciprocals. You flip one to get the other. Tangent and cotangent are reciprocals. Flip one to get the other. With cofunctions, we're going to pair them up, but we're going to pair them up a little different. Let's say we had sine. Anybody have a guess what trig function I would pair this up with?
Cosine.
And it would be its co-function.
Cosine.
You put the word co in front of it. Yep. Sine and cosine are called co-functions because one of them has the word co in front of
Tangent
it.
and cotangent are cofactions?
Tangent and cotangent. Now those are also reciprocals. They're the only pair that happen to be both. And what about secant?
Cosecant.
Cosecant.
Yeah, I got that written right there. So these are what we call the three pairs of cofunctions. Sine and cosine, secant, cosecant, tangent, cotangent. Okay, those are called reciprocal functions. I'm sorry, cofunctions. Cofunctions.
Alright, this time's
Ooh,
not
Hager
bad.
knows.
Who?
Me too, girl.
Okay, any questions on those pair of cofunctions?
Nope.
All right, now, we're going to put the idea of cofunctions and complementary angles together.
This sounds goofy.
When we're solving a right triangle, that's the diagram we're generally going
What's a little
to
fish
use.
on the corner?
It's an
Yep, we talk about these labels.
A. An A.
So for the sides, we always use the labels A, B, and C. Okay, do you have to use A, B, and C? No. But
X, Y,
we
Z.
learn Pythagorean theorem, these are the letters we generally use. Now, some books, instead of labeling angles with Greek letters, they'll use capital letters for angles. So the problem with capital letters is depending on which letter you pick, like if you pick C, a capital and a lowercase could look pretty close. So the reason why we use Greek letters is because they don't look anything like the English letters. So it's very clear when I write a Greek letter, I'm talking about an angle.
What's that Greek letter?
That Greek letter is alpha.
Ooh.
I thought it was an
So that's alpha. And that Greek letter
A. It's a B.
is theta.
That's me and
Oh,
Y.
that's your point.
Okay. So again, the point of the Greek letters is that it's very clear. If I say, for example, find alpha, you know I'm asking you to find an angle. If I say find B, you know I'm asking you to find a side. Now, you can draw your triangle facing any way you want. You want to face it that way? That's fine. The only thing that's important is when you label it. Wherever you put A, put alpha opposite. You have to keep A and alpha opposite
Why?
because it's for the formulas I give you won't work if you don't.
Okie dokie.
Okay? So it's just more kind of like mentally to keep track of what's where. So keep A opposite alpha, keep B opposite beta. Okay? And then C, we always keep as the hypotenuse. All right? But again, which way it faces, that doesn't matter at all. Just A and alpha are opposite, and so are B and beta. Okay, so let's make up a couple questions. Okay. This question's not going to have a numerical answer. Okay, it's just going to be something over something. What's the definition of sine?
Opposite over hypotenuse.
Okay. Which angle am I referencing in this question?
Wait, where's theta again?
There's no theta in
Is
this.
it alpha or beta though?
That's alpha.
Okay.
So it's going to be A over
So it's A
So sine is opposite
over
C.
hypotenuse.
So it's C.
C. Okay. Now, I want to make up a different question. Okay, but I want to make it up in a special way.
Ooh, a special way.
What's the
Like
cofunction of that?
Cosine.
Cosine.
Which is
And what angle is complementary?
Beta.
Beta. Let's find that. The cosine of beta. Okay, what's the definition for cosine?
B over C.
What is it again? What name over what?
Hypotenuse over.
Oh,
No, not hypotenuse first. No.
adjacent over hypotenuse.
Adjacent over hypotenuse.
Yeah.
Okay, so from beta.
Wait, for cosine?
Wait, so
Oh,
that's
I'm looking at the wrong
I know what I
thing.
mean. Yeah.
So what side is adjacent
A.
to beta?
I thought cosine was
It's
hypotenuse
B over.
It's A over C.
B over C.
Cosine is
That's
adjacent
cosine.
over hypotenuse.
B over C.
Is that what
Remember-
I had
Oh wait, no, A over C. Yeah.
Remember how we wrote it?
I did. I
Sakatella?
wrote hypotenuse over opposite though.
Cosine is adjacent over hypotenuse.
Do you have all the same ones as well?
Apparently not.
Okay, so what side
That's cosecant.
is adjacent
Cotangent.
to
A.
beta?
So we're
A
still
Over
sine.
C.
over C.
Adjacent over hypotenuse.
So what do you notice about the sine of alpha and the cosine of
They're
beta?
the same.
They came out the same. Yep. Let's try this one. Tangent of alpha. What's the definition of tangent?
Opposite over adjacent.
Opposite over adjacent. So now from alpha, what's opposite?
A. A over B.
And adjacent is B. Okay. Now let's try a different one. What is the co-function of that?
Cotangent.
Cotangent. And
Adjacent
what angle is
over opposite.
complementary to alpha?
Beta. And that's,
Beta.
so that one would be A over B too.
Cotangent is adjacent over opposite, and adjacent to beta is A, and opposite is B. So it came out the same. So look at the pattern. This and question. This and that are what?
The same.
No, they're not the same. They're
They're
Co-function.
co-functions,
Okay.
and this
They're
and this
complementary.
are complementary. Yep. So that is called the complementary angle theorem. Co-functions of complementary angles always come out the same.
There.
Okay? So any two co-functions, as long as the angles are complementary, they will come out the same. All right, so let's try a couple examples. I don't want to know what the sine of 30 is as an answer. I just want to know something else that it's the same as.
Cosine.
So it's the same as the cosine,
60.
co-function of the complement. Yes, the sine of 30 and the cosine of 60 are the same. Okay, and I'll show you why that's helpful in a second. What about tangent of 15?
75. The cotangent is 75.
That would be the same as the cotangent of 75.
Will you have a pencil?
Those are co-functions.
How do you get the angle?
Those are complementary.
How do you get the angle?
They have
They
to
add
be
them to 90?
complementary.
Oh.
Yeah, they add up to 90.
Doofus.
How about the secant of 40?
What, 45?
What's the co-function?
Cosine.
10.
Cosecant.
50.
And what's the complement?
35. 45.
50.
Are you
What?
dumb?
40 plus
Oh, yeah.
what equals 90?
50.
50.
I'm off
Jesus.
6.
It's okay, we'll figure it out. Get upset.
Nobody's saying that.
I was.
So now, how does it help you to know, like, it just doesn't actually give you the answer, it just tells you something else that's the same as it. Well, let's try this. Okay. I want to know what the sine of 15 divided by the cosine of 75 is.
1.
Okay, and here I'd be more interested in, not the answer, but I'd probably ask you to like type it in, like how you would know the answer is 1, because it is
Wait,
1.
how do I
They
make
How do you
equal
get
the same
one?
thing.
Because it's.
So let's
Same thing.
see if we can figure this out. Yep.
Wait a minute.
Okay, what do you know about
They added the 90.
sine?
They're
And cosine.
complementary
Co-function.
co-function.
Those are co-functions. And what about these two angles?
They added to 90.
They're complementary. If you have co-functions of complementary angles, they come out
They're the same.
they come out the same. Right? So what that means is we don't know what the sine of 15 is. We don't know what the cosine of 75 is. But we just know that they're the same. What happens when you divide two things that are the same?
1.
You get 1. Yep. So it's a very specific situation, right? If this was sine of 16 over cosine of 75, well, no, it's not going to work. Okay, it has to be co-functions, and it has to be angles that are complementary. So if you divide two things that are the same, you always get the same number. How about if you multiply two things that are the same? Do you get the same number?
No.
No. 3 times 3 isn't the same as 4 times 4. But 3 divided by 3 and 4 divided by 4, those are the same. Okay, so this trick helps with division. It also helps with one other operation.
Subtraction.
Yes. They also help with subtraction.
Smart will.
0.
Okay. Tangent, cotangent. Those are
Complementary. Or co-function.
co-functions. 12 and 78.
Complementary.
They're complementary. So we don't know what the tangent of 12 is. We don't know what the cotangent of 78 is, but we know that this and that are,
Equal.
they are equal. So you are just subtracting two things that are equal. You don't need to know what they are. They're equal, which means you always get
0.
0. Now, if you try it with addition, if you add two things that are the same, do you always get the same thing?
Wait, what?
If you add two numbers that are the same, like if you subtract two numbers that are the same, you get 0.
No.
But if you add two numbers that are the same,
No.
so it wouldn't really help with addition. So that's the complementary angle theorem. Okay. So any questions on that? All right. So that's the first part of 4.1.
Yay!
You made it. So tomorrow we'll finish 4.1, and then Thursday we'll have our test.
Huzzah!
Okay, so the first part of the homework, that's the yes or no questions from what we did at the beginning. And the second part of the homework, that's the solving or finding the sine and the cosine. Okay, that kind of stuff. All right, so you got a little bit less time than yesterday, but you got about 16 minutes.
Okie dokie.